Hello, everyone. Welcome to this presentation. Today we want to talk about building pipelines for tomorrow. And we'll talk about USD workflows. We talk about how to integrate AI into existing studio workflows and also many other things. And just to our speakers here. So I'm Richard. I'm the founder of Prism. Later on in the presentation, I'll give you a little bit of an insight of all the interesting tools we are working on at the moment for future implementation in Prism. But first, my colleague Konstantin will talk a bit about all the great stuff we added recently to Prism and show you where we are at with our current workflows. And we are also very happy to have the team from Expanse here. So Fredrik, Eilef, and Sigurd will share a bit about their studio and talk a bit about a pipeline for the movie A Mouse Hunt for Christmas, which they released last year. And when building pipelines, it's important to understand that no project is the same as the next one. So the pipeline we are building, it has to be very flexible and it has to work in many different projects. So just to give you an idea on different types of projects which we are supporting with Prism, we have a project here. The first one, it's a student project from MOPA. It was shortlisted for the Oscars. Then the second one, it's an animation series for a preschool audience, which was recently released on Disney Plus and immediately ranked in the top few spots there. Then we have the Armosaurus series, which is a completely different project. It's a live action series with a lot of VFX integration. And then we also have a VFX movie, Hungry, which is going to be released this summer. And it's a horror movie about a hippo, so it's very entertaining. And actually, Konstantin and I, we spent quite a bit of time last year being very involved in that production. So we helped the studio to integrate automation workflows for this hippo, which was animated in Maya and then brought into Houdini for simulations and rendered in Solaris. And a lot of that development also went back into Prism then later on. And now I hand it over to Konstantin, who will give you an update on all the latest developments in Prism.
So hello, everyone, and thank you very much for joining us today. I will cover the major updates and improvements of Prism which take place over the last year, which is mainly the release of new plugins, then an enhanced documentation, and new tools and workflows around scene building and USD. Starting with new plugins, so we refreshed After Effects and Photoshop, and two new plugins joined Prism, so the Execution Graph, our node-based tool to automate pipeline steps, and the I/O tools dedicated for enhancing ingest and delivery operations for clients. The After Effects plugin has received several improvements, like to check for new versions, for example, which allows to scan and updates for new shots and published versions. And compositions can now be added to the After Effects render queue or as well to the Adobe Media Encoder. And the video in the background shows how to publish composition. The Photoshop plugin was rewritten with the Adobe's new plugin framework, UXP. And as we can see in the video, Prism is now much better integrated into the UI. In addition, exporting as PSD file formats is now supported. All right, one moment. The execution graph has been designed for various use cases, including automated project and shot creation, archiving projects, batch publishing or sending notification, among many others. And it's mainly meant for artists, so no coding is required, but can be extended by TDEs via Python. Graphs can be executed via the run button, so the execution always follows from the input along the connection. And to get started, we added a lot of examples to our graph library, which can be downloaded and used as references. Notes can be added via the menu or simply copy and paste it from anywhere, since the files are just JSON data. On the usability side, we added many features, for example, the lazy connection mode to simply and quickly connect nodes, disconnect nodes, and so on. And we have an example for the execution graph, which basically reads asset specifications from a CSV file. We'll then download it from Polyhaven. In the background, the USD file will be restructured and re-layered to fit the pipeline structure. And at the end, we see we generate a play blast of the downloaded asset. So let's have a look at the example. So we can see the graph with different sections. And now it will be executed. And the playblast is generated. So to see what happens behind the scene, we can see the USD file now contains a layered USD structure containing all different departments, and also the object structure was renamed and structured. So the next plugin we want to talk about is the I/O tools. So over the past year, we explored the challenges studios usually face when receiving files from clients or delivering final renders to clients. And client specifications usually are very different from project to project and also not directly matching the studio structures. And based on this research and also a lot of feedback from studios we're working with, we developed dedicated I/O tools. These tools have evolved and become now stable and also feature-rich. This diagram shows basically the main workflow of the I/O tools. So basically the client files arrive, and then the ingest tool takes care to process all the data and bring it into the project. And at the other end, the delivery tool automates the process to get all approved data back to the client. Here we have a more detailed view of the ingest process. So client files arrive, and the ingest tool so the client files usually includes plates, edit references, or color-specific files. They can then be easily dragged and dropped into the ingest tool, and the tool will automatically detect all formats, shot structures based on a config file, and all detections can also be overwritten if needed. Next, the ingest tool will then submit all the files to the render farm, and their batch process of the file copy will take place, but also some color conversion, for example, with a Nuke template, will be done. The converted data will then be written into the project folder structure, and the corresponding shots are created in Prism as well as in Flow or in any other shot tracking like Kitsu or FTrack. Finally, a first shot will be published to Flow. For the delivery process, after all data is collected, like renders or playblast, they can be published as a playlist to Flow. And this playlist is basically the source of the delivery tool, which will then submit all the corresponding files again to the farm. We'll do some color conversion to meet the client-specific requirements. And then we'll also pack the delivery package for final delivery. And here we can see the delivery tool, a screenshot, which basically gives a lot of options to overwrite before doing the final delivery for the client. All right. So then we want to thank the Prism community for developing free community plugins, so SynthEyes, Slack, and Fusion. In addition, over the past year, we improved our documentation. So that's mainly we added new prism-guides. We added more functionality to our documentation in general, and we now have finally a dedicated API documentation. So last summer we released excuse me, the in-depth video series demonstrating best practice Prism USD workflow. So this is basically going through all departments and can be found on our documentation page. So we also added a new type of Prism guides, kind of, which is a bit of a hybrid of clear instructions together with small demo videos. So basically, we always have the publish date at the top, then we have these clear instructions, and then a small video demonstrating the process. Here we can see the API documentation, which is currently, so all Prism open source code is documented there. And one feature to highlight, so basically every function can be, the source code of every function can be expanded like seen on the image. All right. Then we came to the next topic about scene building, which is a Prism core tool designed to automatically build the initial scene file. This involves various steps like applying a frame range, importing available products, and so on. Each step can be enabled based on assets or shots, and also on departments or tasks, so that's very customizable. The scene building is currently available for Houdini, Maya, Nuke, and Blender. Here we can see the scene building specific settings for each DCC, so this can be completely configured independently. And now we want to showcase 2 examples how this would look like in an example. One time is to build a scene for lighting with a traditional Alembic workflow, and another example would be in USD where we build an animation scene. Oh yeah, so we are now in an empty Maya session, and we will run the scene building. And as we can see now, the scene is completely set up and the lighting artist can start. Quickly to recap what happened in the background. So basically the frame range and the FPS got applied. The environment and the camera got imported from layout. The character got imported from surfacing, and the Alembic caches got applied from animation. And the custom post script got executed to enable textured mode in the viewport. For the USD example, we are again in an empty Maya session, and we will run the scene building. And this time the whole animation scene is built. And to recap that as well, sorry. So again, we have got I'm going up to the next slide. Oh, here we are. So again, the frame range got applied, the USD shot container got loaded in, and also the Maya rigs got converted to Maya data, so that basically the animation artist can directly start animating in the scene. All right, so now we come to what happened in USD during the year. So for USD, we added tools for Houdini, Solaris, and Maya, and looked also more into advanced asset structures. First, we will look at the render manager in Houdini Solaris. So here we have a multi-shot lighting scene containing multiple render passes, as well as shot overrides for each render pass. And if we open the render node and the render manager appears, and we can basically enable and switch different render passes, and can also add all available shots and render passes from the scene file. If we set everything up, it could be rendered to the render farm, and we can see the final render passes and AOVs in the Prism project browser. Our next example is about animation curves. So previously in Maya, when we, for example, load a camera from layout in animation, all keyframes are baked. So it's not so easy to adjust them. But now, since Maya supported animation curves, so we also implemented this in Prism, and this means we can now get the initial keyframes from layout and can adjust the animations on top. To quickly recap the advantages of animation curves. So the initial keyframes stay intact. USD files are much more lightweight because they store only the keyframes which were set. And cameras can be basically added in every department later on. So this is currently limited to cameras in Maya, but we're really looking forward when this will finally maybe also be available for animated data. The next example would be a variant tool. So in Maya, we implemented a quick variant setup tool where we can basically, for example, set up geometry variants about the attached tool to the character's arm. And we can then switch it on and off. And finally, we will talk about some USD asset structure. So USD comes with many concepts to work with assets. We upgrade our example character, so we have now geometry and material variants. Since the character was modeled using subdivision surface, we can also set the level of detail quickly in USD. And the character also comes with now a proxy and a render geometry to optimize scenes. And in addition, we also have now a kind support. So this can be super handy. For example, this character is used with subcomponents. So for example, in the rigging stage, you can select the moving parts, which will be rigged later on. All right, and here we have an overview about some more features and improvements over the last year. And yeah, that's it from my side. And now I'm glad to hand over to the Expanse team.
Is it working? Yeah. First of all, thanks to Richard and Konstantin for the invitation. We've been fans of Prism for a long time, and we've been users for a long time. So being here to share our know-how means a lot to us. My name is Fredrik Fottland. I'm the CEO, owner, and VFX supervisor at Expanse. I'm going to do a speed run of who we are and what we do. So let's start by showing you some of our previous work. So being a small studio in Oslo means we work with low budgets. We don't have good film incentives in Norway, and with a population of 5.6 million, the box office potential is limited. But our clients expect high quality, both when it comes to delivery time and quality. So when we started out 10 years ago, we knew pipeline was key to the success. Not nice to have, but the only way a small studio can deliver at the level we wanted to. A Mouse Hunt for Christmas, or Hvis ingen går I fella, is our second live-action animated feature film. We produced it last year from January to October, and it was released in the cinemas in November 2025 as a Christmas film. It sold 460,000 tickets in Norway, making it the biggest box office last year, beating both Minecraft and Avatar in Norway. And it ended up selling 2.2 million tickets across Europe. Here's behind the scenes of the work we did. Expanse was the sole animation vendor on the project, and we delivered 32 minutes of animated mice spread across nearly 500 shots. Some that included digital snow, smoke, lasers, liquid, and demolition. With a tight deadline and budget, the only reason we made it was thanks to an amazing team and a solid pipeline based around Prism 2. With limited resources, tools we use at Expanse should just work. And Prism 2 delivers on that across our core software, Houdini, Maya, Nuke, and Flow. Another key feature is that we can expand and make our own tools if a project needs it. And last but not least, our artists should create, not spend time messing around in a clunky pipeline. Prism 2 is user-friendly and easy to pick up, making it the perfect match for Expanse. So moving forward, our next big project is a 3D animated feature film called Fast Forward. And you're now going to see an exclusive world premiere of our sales teaser that's going to be screened at the sales market in Cannes next week. Some Star Wars-inspired music there. So even though we're a small team at Expanse, we're rigged to scale up with freelancers for larger projects. And with Prism 2, we see that we are able to collaborate more closely with other studios using Prism 2. On the mice hunt, Haymaker, who was another VFX vendor who did some of the external shots, we're also using Prism 2. So if you want to talk pipeline or anything else, you come find us. I'll now hand it over to Eilef and Sigurd, who built and breathe our pipeline every day.
Hello, I'm Sigurd. I'm a CG supervisor and pipeline TD at Expanse. I'll talk a bit about the technical steps between... What? Can you hear me? All right. Yeah, so I'm Sigurd, pipeline TD and CG supervisor at Expanse, and I will talk a little bit about all the steps from start of product, production until animation. So Prism was an ideal pipeline choice for us, coming from existing shot grid workflow. We adopted early in Prism 1 and made a lot of custom tools that we have brought with us with Prism 2. And these developers have made a lot of good improvements that we look forward to implement in our future productions. So Prism has a lot of native plugins that just works with an integration with apps that we use out of the box, and has a very good sync solution with Flow. And it's very easy to use and deploy. And it's very customizable with hooks and Python scripts that you can use on top of the existing Prism core modules, making it great to push information between our applications. For us, automation is important to minimize tedious manual tasks and eliminate human errors, and letting our artists be creative and focus on their tasks. And we do a lot of frequent publishes for reviews, so we can have all the producers and supervisors actively in the loop, and keep a good version control and sanity checks for all departments. Yes, we use Flow as an online database and platform to set up and deploy assets and shots, and also for media storage that we use for reviews and playlists. And Prism syncs the info from Flow and gives a powerful project browser and application integrations to work on our local files. And for shot setups, we made an in-house plugin for Hero, based on the Prism plugin for Nuke that already ships. And for that one, we export plates and audio into the Prism folders, so we can easily access them with our other software. And from Hero, with our tool, we sync our timeline to Flow, so we get all the frame ranges and shots, and add the task presets. And then everything is accessible from the project browser in Prism afterwards. For assets, we use the state manager, and we can define what we want to export. So we use export the root to a Maya rig file and then we export the USDs just of the geometry that we can use for texturing, surface, and various Houdini tasks. And also an Alembic file for a legacy workflow that doesn't support USD yet. And for animation scene setups, we use a custom tool that lists all assets in the project and can import the rigs from those, and also a multiplier so we can import as many as we want if needed. And Prism is very nice with setting frame ranges and resolutions for us. Then we set up a scene structure that works with Houdini and import some audio. And then we have a playbus tool that comes with a preset for how it should look with textures, ambient occlusion, and then burn-in. So the other departments can see all the technicals for the cameras and frame ranges and stuff. And we publish to Flow for reviews, and from every export USDs, and assign various attributes that's needed for Houdini to work properly with our USDs from Maya. And we send a submitter job to deadline. And that splits up all the assets into different jobs so that we can get them up quite fast through the render farm and update statuses directly from there. And then we have a checksum in ShotGrid that shows what's the latest version of animation through all the used in all the steps, all from play blasts and USD caches, light, and comp. And that's it for me. Eilef.
Hello. Yeah, so my name is Eilef Sandnæs. I'm a CG supervisor at TD. I'm the one that deals with the most of what happens after animation caches have left Maya into the CG pipeline and the USD part of the pipeline. This is what I'm going to show a brief overview of now. Yeah, so we have been using Solaris and USD for many years now. Our first test project was back in 2021. We were using Prism 1 at the time. Prism 1 did not have any tool specific for Solaris or USD, but this project was one shot and 2 characters, so Alembic caches and shaders was assembled manual. It was a great little project to test Solaris. So our first big Solaris and USD project was in 2023. We were still using Prism 1 and Alembic caches. Shader assignment was automatic. At the time, we would have a subnet for each shot in a sequence, and the subnet would contain all Alembic caches and shaders. We did not have any great setup for FX caches. They would have to be imported manually. So yeah, our first big project using Prism 2 was in 2024. Now we have switched to USD caches from Maya. This solved the vertex order issues we had to deal with in the past. In the past, only shader assignment had been automatic, but because we now have had switched to Prism 2, automatic FX layering was up and running. This project had a lot of water simulations, so being able to export the simulation and they would appear in the correct location of the USD layers saved us a lot of time. We was also lucky that Houdini just got the ocean procedural. It was perfect for this project that had a lot of oceans and water. Yeah, what I'm going to talk about now is the USD assemble script. This is the script that brings the caches from Maya into the USD pipeline. The script runs after animation caching is completed on deadline. It will create 3 USD layers: animation USD, animation USD look, and animation USD utilities. So the first layer is the animation layer, where all the animation caches is combined. More happens on this layer, but I don't have time to talk about it. It gets saved as layer animation USD. And then we have the look layer. This is the layer for shaders and groom. The script will search the animation layer for assets and assign the latest look version in the project using the prism-Python API. When the look assignment is completed, it gets saved as the layer animation USD look. Whiskers still has issues, as you can see, but it will be fixed in the next layer. So the next layer is the utilities layer. This layer is for cleanup and overrides and more. The whisker gets fixed in this layer. The issue with the whiskers comes from the layer stack. The animation layer is above the look layer, and Maya wants the curves to have a 1 in width. So this layer is above the animation layer in the stack and brings back the correct values. Velocities is also generated in this layer. This is used for motion blur on procedurals. We use procedurals for hair deformation. And the last part is the fault group and icons. When it's all done, it gets saved as linear layer animation USD utilities, and now the shot USD is ready. Before I show our Solaris setup, I will talk about HDRs. And on our VFX project, we always try to get the HDR for each location and new light setup. The mice movie, we ended up with 320. Each HDR is made by 7 DNG files taken at different exposures. Our HDR workflow is a journey between many softwares. Because of this, we are using Houdini PGG as a hub to manage them all. This makes it possible to batch convert them all. When the process is completed, they will be inside the HDR asset folder of the project. We are using year, date, and time naming scheme to make it easy to find correct HDR for a shot by looking at the metadata of the shot plate. Like in this example, you can see the time code and date at the top left, hopefully. Yeah. The last week is done inside Nuke. HDR and plate color checker needs to be matched. We also split the lights into different images. This is to give us more flexibility in the light scene, light group AOEs, and happy compers. This is an example of our setup, of how our setup looks in Solaris. It contains 7 shots and 3 light setups. At the top, we import all the shots in a sequence with the Prism import nodes. You may notice that we have a node between the Prism node and the shot switcher. This is because we want to edit the shots without breaking the shot switcher, like on the shot to the right in the image. Underneath, we have a shot switcher. We have global overrides, for global overrides, and procedural preview node that we can turn on and off with a global context variable. Then we have a render settings node at the top. We're also using a modified background plate node, giving us more flexibility to how much light is bounced back from the background. The EXP set background node will get the information from the camera about image planes that has been used in Maya. So we get the same background plate that was used in the animation scene. It will then override the background plate shader and the EPAR filter, so we get identical match to what was used in Maya. Yeah, here it just shows where we have our blockers and reflectors. We use a HDI for it, so artists don't have to worry about folder structure or shaders when adding blockers and reflectors. Just load the HDI and you're ready to go. This is our default lights. They have light group names and it's ready to be used. Underneath, we have some last week that happens to the light. We had the light group prefix to all the light group names, so it's easier to get them with the scripting down the pipeline. And then all the new render bars will be added to the product list, so we can actually see them in our render view. Then comes the light linker and light mixer, where the light adjustment happens. This is how we do our render layer setup. The last word in the submitter name is a context variable that switches to the correct layer. Example, if the last word is char, the render layer switch will choose layer char. Yeah. Now that you know how our setup works, let's talk a little bit more about how we do lighting. The first step we do is to match the gray ball, so we get a good initial light match. To help with this, we have a node using Copernicus to compute the difference between the plate and the CG gray ball. It can show the difference in the viewport as a heat map for each color channel. So here we have the gray ball plate. And this is how the CG gray and grayscale looks when using the HDR. This does not match the plates grayscale 100%, so the light setter needs some more work. So this is how the heat map looks. It's showing the difference in value for one color channel. Ideally, after tweaking, it should look more like this. Getting a perfect light match is not easy to do, but this node makes it easier to get in closer. Our setup for the mice move was char and shadow layer. So here you just can see our default AOEs that was used to make the compositor's job easier. Then we have the shadow layer. This is mainly contains shadows. Why we split char and shadow is because we don't want to deal with edge issues in compositing. We're also doing a depth of field in comp, so having char and shadow in the same layer would make some horrible edges using the bokeh node in Nuke. But before we send the slow main renders to the farm, we do our previous Slapcomp render. It's half resolution and low samples. It gets completed on the farm relatively fast. We do these previews to find issues, so we don't waste a lot of render time on renders we can't use because something was wrong in the scene. The Slapcomps is done with the Copernicus. Yeah, so this is how the render looks in Prism Meta Browser. If you look at the middle where you see all the versions, you will see a comment with all the render layers. That's in the version. Doing it this way, the compers can easily see what's inside the version. And that's all I had time to talk about.
All right, very cool, thanks. So for this last section of this talk, I want to talk a bit about the future development in Prism, and I want to show you a couple of examples of things we are working on at the moment. So usually we work on 20 plus things at the same time. So today I want to focus mostly on editorial, multi-shot, and also some AI tools. So let's start with editorial. And for that part, we integrated OpenTimelineIO in Prism. So OpenTimelineIO is an open source framework to exchange editorial data between different applications. And it comes with an API and a lot of other very nice things to integrate it. So by integrating it to Prism, of course, we made sure that Prism can import-export these timelines from different DCCs, for example, like Resolve or RV. Prism then takes care of all the versioning of these timelines, but we also wanted to find ways how to automatically create new timelines. And the perfect tool for that is the Prism Execution Graph, which was mentioned earlier already. So we created a few custom nodes for that, for example, to create a new timeline, create new tracks, and add clips to that timeline, and then save out that timeline. So we can use that to automatically build new timelines from whole sequences with all the latest versions. And another example would be to take an existing timeline and just update existing clips on it so that we can always rerun that to always every day get the latest versions of the renders on our timeline and to review it. So let's have a look at an example how that looks in practice. So first here we have a section where we get all the latest renders from our project. Then we create a timeline, save that out. And in the end, we open RV and we load that timeline in RV so that we can play it back and take a look at the whole sequence. And this is the result we get, and we can run that every day again to get always the latest updates. We also updated the RV integration. So as you can see here at the bottom, we have some timeline panel. So we can reorder different versions. We can switch them to different departments. For example, here I'm going to switch it to the animation playblast so we can see how it progresses. We have a search bar on the side where we can get all the latest versions or also previous versions from the project, add that to our timeline. And in the end, we can publish that as a new version of our timeline. And from there, we can get it into other DCCs, for example, DaVinci Resolve, or we can also get it into Blender, into the video sequencer there. And now for the next part, I quickly want to talk about Multishot workflows. And we already have a Multishot workflow in Houdini Solaris for lighting. And we wanted to extend that to also integrate Houdini Copernicus, the 2D context in Houdini, into the Multishot workflow. So we integrated that also into the scene building so that we set up a new lighting scene. We also get this shot switch with the Slapcomps created. So a Slapcomp in Houdini basically lets the lighting artist see the completely comped shot while doing the lighting renders in the viewport. And it can also be applied automatically when doing the final renders in the end. So here's an example. So we start building our lighting scene. Prism creates all the templates for us, sets up the lighting scene with a shot switch, And it also creates the Slapcomp here. So it has a section for every shot in our scene. And now we can add, for example, color correct for this specific shot, see it in the viewport, and we can switch to other shots which don't have this specific color correction applied. And we can then take also this specific, these nodes and publish that as a Slapcomp into our project, so it gets versioned. And publishing these nodes is using the Houdini recipes. And we can also build full libraries with that. So we can select some of these nodes for our Slapcomp and save that into our Prism library. And we can choose a custom thumbnail for that. And this way we can build a full studio library or project library for reusable templates for these little tools to use Slapcomps for other sequences, other projects, and so on. With the recent releases of Nuke, specifically Nuke 16 and 17, there is also a new concept of the graph scope variables, which also allows us to integrate multi-shot workflows into Nuke directly. And of course, we also integrated that in the Prism scene building. So again, let's start from an empty scene and build our comp for the whole sequence. So Prism automatically loads in our renders. It sets up a shot switch here at the top so that we can cycle through all our shots. Then we can do, for example, color correction or other modifications to a specific shot, view that in the viewer, and then switch to other shots and make shot overrides per shot. In the end, of course, we can then render all our shots. So in this case, we can select all the shots we want and submit them to Deadline to render them. And Prism will cycle through all of them and submit all of them as separate jobs to Deadline. Okay, but that was just a very simple example. Like, more commonly, you would have separate layers of your renders, of your shots. So in this case, we have separate render layers. And we also made sure that the Multishot workflow supports this kind of comp setup. So that we have a character layer here in this case. We can set up shot overrides for this specific render layer. And then add, again, for example, a color correction just for that shot for this specific render layer. Okay, so now to the next part, which is the AI integration. So there are two subtopics, and the first subtopic here is a ComfyUI integration. So ComfyUI is an open source tool. It's a node-based graph, mostly to generate images and videos using different AI models. And since it's open source, it has a pretty big community and a lot of custom extensions. And more studios also want to integrate ComfyUI into their workflows to see how they can integrate that, what it brings to their workflow. So we started to exploring that, and in our first prototype, of course, we basically just handle it just like any other DCC. So we started by adding a Prism menu here, and from here we can open the Prism project browser, and so every Prism user will already feel very familiar. And we can now save our scene files here, we can load previous versions of it, and basically keep track of our ComfyUI workflows. Then the next step, of course, is to bring in media into ComfyUI from our project. For example, if we have some Maya playblast, we can load in videos, we can bring in EXR files with color space conversions, and we can even bring in whole 3D assets. So here in this case, I have a 3D robot asset. And as you can see, we can bring that in. It even comes with some basic materials, and we can use that for automatic unwrapping or doing some remeshing on that asset. So once we generated some media in ComfyUI, of course, we also want to bring it back out of ComfyUI, back in the pipeline, to maybe hand it over to colleagues or bring it back into other DCCs. So we have a custom Prism export node. And with that, we can export the generations in the Prism project. And from there, we can go into other DCCs and continue working with these medias. So once the ComfyUI graphs are generated, oftentimes you want to run them over and over again, just with different inputs. So you change the input image or video and run the ComfyUI graph to generate some different style or another output from it. So we integrated that into the Prism Execution Graph. So we can trigger the ComfyUI workflows with this. And I want to show you an example on how this can be used. So here I start with a ComfyUI graph, which takes a video input and a few reference images from some of our shots in our sequence. So now you can imagine we want to start on a new shot. So we are doing some layout and animation on this new shot. We don't have the lighting ready yet. So we just start creating a playblast. And Prism will automatically in the background submit a job to Deadline to run the ComfyUI graph. And after about a minute or so, that completes. And it gives us a video which looks like this, which takes the lighting and materials from the other shots and applies it to the playblast of our new shot. So we can compare it here in RV and see how it looks. Like, it's not perfect, but it already gives us a pretty good impression on how the shot will look with the final lighting in the end. So in our edit, we can then also switch the playblast to the generated lighting with materials and see how the whole sequence looks together. And then if we like how the camera looks, we can then continue to do the final render in Houdini. So you can imagine, like, for the ComfyUI, that's just like the start. There are like many other possibilities which can be done with these workflows. And now for the last section of this talk, I want to talk about agents and see how that can help to use a pipeline. So agents are already pretty common for developers. Like many TDs who are writing a lot of code are already heavily relying on agents to some degree. And we want to see how this can be also used in pipelines. So we started very simple. So we created a little chatbot which can tell us stuff about Prism, who gives us answers about that. Initially, it was not very helpful because it was making stuff up. So we made sure that now there are sources for everything that it gives us for information. So we can click on the sources, and it brings us to the handwritten documentation. And the best thing is actually if I ask it now about stuff which does not exist, it will actually tell us that it cannot find information about it. So that we can actually rely on it. If it gives us something, then we can also verify if it's really true. So far it's just an assistant, but to be really an agent, it actually should do stuff for us. And this is where an MCP comes in, which is the Model Context Protocol, which is a way of a large language model to communicate with an API of a software like Prism. So with an MCP, the LLM client, for example here, the Claude app, can communicate with Prism. So we can ask it about, give us a list of all the assets in our project, or we can ask it to give us a list of all the tasks which are not completed yet. Or we can also, here in this case, let us create shots in Prism for us, and we can check in the project browser, and it actually does the stuff for us. So another example would be to bring that into our Prism agent. And here we can also let it open assets for us. So I can ask it to find a specific asset, even if I don't know the specific name, find the latest USD representation of it, and show us how it looks in the USD viewport. It can also batch run over multiple assets. So I can ask it to get all the assets of a specific category, get the latest renders of it, and then compare all of these renders for us in RV. So we get a pretty good overview very quickly of the content in our project. Of course, we can also use that within DCCs. So we can let it publish, for example, animation caches for us in Maya, and it will run through all the characters which it finds in the scene and publishes that for us. So we can also use it to let it configure all the USD export settings for us or help us troubleshoot if there are any issues with the export. So the problem is a bit that now we have like all these different tools, but we would need to know the prism-Python API and give the agent all these different tools so that the agent knows how to use it. So we found like an easier way to combine all these different tools is to use the Prism Execution Graph. So basically now the agent only needs to know how to run the execution graph. And the execution graph, it already has access to the USD API, to Houdini API, basically to all the Prism features. And now we can build simple graphs ourselves without any coding knowledge. We don't need to know any Python for that. We can just build simple graphs like this, which takes a media input and then converts it to, for example, an MP4 file with some burn-ins. Another example would be a graph like this, which publishes a media file to Kitsu and adds some optional description to it. When we combine all that, we can then give these graphs as tools to the agent and ask it, for example, to get the latest shot and find like the latest renders of it, convert it with burn-ins, and publish that to Kitsu for us. And the agent automatically figures out like in which order to run these graphs, how often to run these, on which assets to run these. So it can save us a lot of time, and we can run it over the whole project, basically. And yeah, you can imagine that there are many different ways how you can use this. And yeah, since it becomes like very easy to set up, yeah, I think there are a lot of possibilities with this. But I think it's also important, yeah, to mention that there's a lot of hype around all these AI tools recently. So it's also important to stay realistic, and not everything which looks great at first is also really helpful in the end in the production. So yeah, we'd like to really focus on the things which really can be used in production later on. And yeah, like for some studios, these AI tools might be some option to integrate into their pipeline, but not for all studios. And yeah, like our main goal stays how it always was, to just help different studios to integrate all the tools they like into their pipeline to fulfill their creative vision, and whether or not it integrates AI. And yeah, that's it from us for today. Thank you very much. Any questions? Oh, yeah? Yes, over there.
Maybe a question for the Expanse team. Because from your slides, you basically said you go from Maya to Houdini later on, correct? And for the shading part, are you using Material X, since that's kind of like the prevalent shading system, I guess, or the future-facing shading system of both DCCs, or is that something that's not really relevant here, since the more final end of the pipeline is on Houdini anyways?
We're using Karma XPU for the mice, so yeah, it's Material X, but with the custom Karma shader for fur. That's yeah.
Roy?
Okay. Hi. I would like to ask if the docs for, like at the beginning you were showing the page with the docs for for API, which I think it's new. Is that already online?
Yes, I think we released it a couple of weeks ago. It's already online. It's linked in the user documentation.
Right.
You should be able to find it online. Otherwise, send us a message.
Yeah,
and
awesome.
we
Thank
point
you.
you to it.
Have you already looked at different farm renderers or farm managers than Deadline, with Deadline being end of life now?
We always try to look around on what's out there and yeah, see which one makes sense to integrate. But in the end, the time we invest in that research also depends a bit on the requests from the studios. And so far, there hasn't been that many studios yet who really are ready to move away from Deadline. So we start looking into other options, but still Deadline will still be the main render manager for the foreseeable future.
Any other questions?
So, hi. For small teams where keeping track of production is a big of an overhead, how confident are you to giving production-like tasks for the agent? For example, if you want to populate a couple of shots with your template files and render it through your pipeline, how realistic is this?
To run it through an agent?
So, for example, if you have 5 new shots, you have to quickly create with known assets. How realistic that you can trust your agent with these tasks? Just to populate, put down the first version of the scene file from a template or from a library and render it out via Deadline, run it through a default or a preset comp file you created in Nuke, and compile it into an MP4 and upload it to FTrack.
Like creating a first version of a shot, it's not that complicated actually. So you can actually already build a full execution graph with that, and basically use that and give it to the agent and let just the agent run it with different shot names. I mean, the agent thing is still like very early we still need to test it more, obviously, and we also need to get studio feedback on that to see how reliable it actually will be. I think there will be definitely use cases for it to some degree, and yeah, but I think a first version should be quite possible.
Just to follow up, as a studio, I don't think I would let Claude loose in my feature film projects, changing stuff, but for a commercial, it could be a test case.
Yeah, like also to add on that, like it's also a big difference if you let Claude or any AI to access the whole API, or if you just give it access to one specific execution graph. So if it just has access to this one execution graph, it cannot do other things. It can only run that specific thing. It could not move data or delete data. So of course I understand the concern to let any agent touch anything of the production files, which is also totally fine. But I think there will be more and more guardrails to direct it to what it's allowed to do and what not.
Yeah, that would be my other question, where the inference is happening.
I'm sorry?
Where the inference is happening behind the LLM.
Sorry, could you repeat?
Yeah, so the inference, where the agents, what's the model behind the agent?
Oh, that's very flexible. Like it's not hard-coded in any way. Okay. Like for our examples, we used Claude, the Claude API, but you could also use any other local agent if you like to.
Thank you.
I just wanted to ask for the ComfyUI part. Well, I know for a fact that AI has always that problem with like the consistency when taking shots and like keeping everything the same in every single shot. How could you, like, if you want to render like more than 15 seconds shot, I'm not talking like a final production, just maybe for previs. How could you make it always consistent and keep always the same materials, same lighting, and with different camera perspectives that the AI does not really destroy the whole shot?
Yeah, that's a very good question, and I think there's probably not the perfect solution for that yet. I mean, basically every week we are seeing like some new developments and some progress in that direction. I think it's not perfectly solved yet, but on the other hand, I don't really see it, at least at this point, as like our main goal to figure out how to do the ComfyUI graphs. Like for us, the main focus is a bit more like if studios really want to integrate that into their workflow, we can help them to automate different steps, like bringing data in and getting data out. But how to actually design the ComfyUI graphs, at least at this point, it's still a bit more up to the studio, and things are still changing quite fast. So maybe something which is true today might have a much better approach already a few weeks from now. So yeah, that's...
And the example you showed, you used the Playblast. So the Playblast has the camera, it has the character, it has the motion, it has a lot of information. So you get kind of a good representation. And when you have the other shots around as references, you get kind of somewhere that's pretty close to where you end up, and it's not meant to replace rendering. It's meant to give you an insight into where you're heading with the shot. And
yeah, exactly.
Doing that in the Playblast for the animator.
And if you're doing actual renders, of course you can also render out different passes and use that to guide the video generation. So depending on which models you're using and which input sources you have, you can get directed a bit better. And yeah, it depends also on what your expected output is, like what quality you want to get in the end.
Yeah, just to maybe get back to the MCP or AI question on whether you would let that loose on your production. With the AI, like it doesn't touch your, like you said, it doesn't touch your actual APIs. It just touches, like you can run these tools. But I think the magic in, like if you ask it now, please make, like convert this and do this, it will figure it out and it will start running it. And then you're like, okay, this is a pretty cool action. I want to do this now 100 times across something else. I think the real magic starts happening if you are able to use the agent as like the prototyping tool. And as it runs it, you are recording the actions so that later you can essentially re-execute that graph that it almost made itself. And that way you can essentially prototype your production workflows. And in the end, all you're changing are the inputs, but you know that it will next time be only running that instead of, hey, I'm using a new model and I'm inventing that I'm using another node, which makes it very unreliable. But you can test it on one project, which can make reliable, reproducible actions like you would in Photoshop. You would record your actions.
So you also mean like something that the agent would generate a graph for you? So
not necessarily. I think in this case, you ask the agent to do something. It will trigger a sequence of MCP calls, right? All you would need to do is, okay, these MCP calls have some inputs. I need to record that as an action, and then I can just re-trigger those actions. So all the AI agent that essentially ends up being is like an action builder, so that you kind of what you would do in Photoshop. If you have like some reproducible steps, you can record your actions, and you can just start doing stuff in Photoshop, and then you can trigger that on your image the next time. In this case, the AI agent would be doing similar with the MCP calls, where it just does something, and you're like, oh, this was actually pretty cool. I want to reproduce this now on my actual production product, without it trying to imagine new stuff the next time I'm asking it.
Yeah, I absolutely agree. It probably makes sense for every studio to run first different ideas in the sandbox environment before, letting it touch anything else. Okay, do we have one more question? Oh, sorry. Very short question.
That was a really good presentation. Thank you. Every project presents such a different challenge. What is, for Prism, your long-term philosophy? Do you want a tool with a solid core that studio can customize, or a big tool who can handle all challenge?
Like, it will be difficult to make a tool which will be perfect for everyone, but like our main goal is basically that studios can work without with forgetting the pipeline around it, so that it becomes very natural for them to use it, so that they don't have to worry about it. They just know, okay, it works. Maybe studios, at least the artists, they don't need to know how it works in the background. It should just help the artist to create the animation or the VFX project in the end without letting the artist worry about it. Of course, it has to be extendable by TDs from studios, but that's more like a bonus on top. Okay, thank you very much.